Okay, stats, this is the last and the third and hopefully shortest section of 5-1 notes. I have a third part assigned to you for homework up on the online homework page. So this is part 2. There's one example that we're going to go through here, and then we are going to go through this last example here, and that should be about it. So this first thing is talking about expected value. This example is talking about expected value, and expected value is what, given a scenario, what you can expect to happen. Like when, and this a lot of times breaks down into gambling or things like that. When you're gambling or when you're putting money into a pot, how much can I expect to gain? How much can I expect to lose each time? Okay. And another term for expected value is finding the mean. So we are finding the mean of a probability distribution, and we know how to do that. We've done that up here, where you just take the x's and you multiply by the probability of those happening and then add them all together. Okay, so we're going to see kind of how this breaks down. We have two choices here. We have $5 to place a bet on in the Golden Nugget Casino in Las Vegas. You have narrowed your choices down to one of two bets. You could first play the roulette, and in roulette, I had to look this up, there are 38 numbers, and you spin it or whatever, and you want to bet on the number 7 in roulette. Okay, so what's going to happen is your chances of winning, the probability of winning, is 1 out of 38, right? If there's 38 slots, then there's only 1 7 on the slot. You have a 1 out of 38 chance of winning, okay? The second thing that I could do is I could go to the craps table and I could bet on the pass line. I had to look this up as well. But the probability of winning in the pass line on the game of craps is 244 out of 495. So it's not quite 50-50 chance of winning, but it's pretty close to that, okay? Usually the odds are, the odds are always in favor of the casino. So your probability of winning is always going to be less than half. Then if it's close to 50-50, they're always going to make it less than 50-50 in your favor so that they make money, okay? So part A is going to discuss the roulette game. So if you bet $5 on the number 7 in roulette, the probability of losing $5 is 37 out of 38. Probability of winning is 1 out of 38. So 37 out of 38 are my chances of winning, okay? Are my chances of losing. And the probability of making a net gain of 175 is 1 out of 38. The prize is $180. I don't know if they told us that. Including your $5 bet. So the net gain is 175. So I'm going to make $175. Find your expected value. So what we need to do is we just need to organize this kind of into a table and take my x's times my probability. Okay. So the two options that I have is that I could lose or I could win. Okay, the probability that I'm going to lose is 37 out of 38. The probability that I'm going to win is 1 out of 38. Okay, if I lose, I'm going to lose $5. If I win, I'm going to net gain $175. So that's kind of how those break down. So what I do is I multiply them together, multiply the probabilities. So $5 times 37 over 38 is a negative 4 whatever that is, 868421, and they go out a lot of decimal places, okay? And then the chances of me winning $175 is 1 out of 38, and if I multiply those together, I get 4.6052. And just like we were finding mean up here in this table, we add those two together, and when you add them together, you can expect to lose 26 cents each time you play the game in roulette on average. Now, that doesn't mean I'm going to lose 26 cents every time, because sometimes I'm going to win 175, but most of the time I'm going to lose $5. So if I keep playing and keep playing and keep playing and keep playing over and over again, it will average out to be about 26 cents lost per time that I do, that I play the game, okay? Now, that is as compared to the game of craps, okay? So we said that there was a 244 out of 495 chance of winning. That means there's a 251 out of 495. I think I said that wrong. 251 out of 495 chances of losing. So lose and win. Those are my two options, okay? Let's talk about what they're betting. If you bet $5 in the pass line and win, you are given $10 that includes your bet. So you gain $5. So you're either gaining 5, or you're losing 5. Gain 5 or lose 5, okay? So if I lose, so I'm losing versus winning. Losing, I have a 251 out of 495 chance of losing. That's what we labeled up here. If I lose, I'm going to lose $5, okay? Win. Oh, I don't know why I did that fancy circle. That's interesting. Okay, 244 out of 495 are my chances of winning, and if I win, I'm going to win $5. So I multiply those together, just like we're finding the mean, okay? And I get this number, and when I add those together, it gives me negative 0.07, which means I'm going to lose on average 7 cents per time I lose, okay? So, or per time I play the game. Okay, so now we have to decide which one we're going to do. Here, I can, on average, I'm going to lose 26 cents per game, but here I'm only going to lose 7 cents per game on average. Okay, now a lot of people think that this game is more appealing because the payout is a lot better if you win, right? $175 looks more appealing than winning 10 bucks. Okay, but on average, this game will, the game of craps is going to lose you less money overall. Both of them are going to lose money on average, always. If you keep playing the game, it's going to average out to be 26 cents lost versus 7 cents lost every single time. But if you want to lose less, you're going to play the game of craps, okay? So that's kind of how that is narrowed down, okay? There's a lot of probability and a lot of this stuff that goes into setting up the game, games in casinos and stuff. Okay, now we're going to do another example like that where we have to set it up by ourselves, but this is not a gambling thing, although it still involves risk. We're talking about insurance, okay? I always said that if I wasn't going to be a math teacher, I wanted to be an actuary for an insurance company because they deal with this stuff all the time. They're dealing with probabilities all day long, and they want to make sure that in the end, the insurance company comes out on top. And are making money. So they take premiums from every person that is insured every month. And then, you know, yes, you're going to have a claim, but they're hoping that the amount of money that they have to pay out to people ends up being less than the amount of money that they take in. Okay, so there is a 99.88 probability that a randomly selected 31-year-old male lives through the year. Well, that's exciting. So there's like a less than 1% chance that they're going to die, the 31-year-old male, okay? A life insurance company charges $175 for ensuring that a male will live through the year. If the male does not survive, the policy pays out $110,000 as a death benefit. Complete parts A through C below. From the perspective of the 31-year-old male, what are the monetary values corresponding to the two events of surviving the year and not surviving? So if I survive the year, I'm going to lose money. I'm going to go negative amount of money. And I'm not just going to go negative $175. I'm going to go, oh, yes, wait. A life insurance company charges $175 for ensuring that the male will live through the year. Okay, so it is $175 a year. I thought maybe that was per month. That would really suck. That's a really bad insurance policy if that's the case. But $175 a year, so they're going to lose $175 if they survive the year. If they die, they're going to make plus $110,000. Really, they're not going to make it. Their family members are going to make $110,000. Okay, so if they survive, they lose $175,000. If they die, they make $110,000. Okay. If the 31-year-old male purchases the policy, what is his expected value? Okay, so the two things that I have are survive and die. This sounds really morbid, but whatever. Okay, survive and die. So we're going to put the P of X over here, the probability of that happening, and then we're going to put our X's over here. So if I survive, I'm going to lose $175,000. If I die, I'm going to plus $110,000. Okay, the probability of surviving, though, is 0.9988. That means that my probability of dying is 0.0012. Let me check that to make sure that I'm doing those decimals. It's been a long day, so just Bear with me. Yes, okay. So that's my x's are the amount of money that I'm going to make or lose, and my p of x's are the probability of that happening. So all I need to do is multiply those guys together, and then add my final result. Okay, so I have 175 times 0.9988, but it's going to be negative, so negative 174.79. All right, and then 110,000 times 0.0012 is positive 132, even $132. Okay, so if I add those together, minus 174.79, the end result, if I add these two together, the end result is going to be negative 42.79. Okay, now let's think about what that means. In the end, I'm going to come out as a negative number, which means the insurance company is going to make money. This is negative from the perspective of the 31-year-old male. That's what we're going from. So from the perspective of the 31-year-old male, he's going to lose $42.79 on the deal per year on average. On average, he's going to lose $42.79, okay? Because insurance companies bank on the fact that you're not going to die at the end of the year, okay? So can the insurance company expect to make a profit from many such policies? Yes. Yes, they make $42.79 on average per year on each male that is insured. Okay, now I'm guessing that if it's a 31-year-old male, it's going to have a different probability of living versus dying than a 32-year-old male. So we would maybe have to change that in the next year. Maybe the chances of the probability of dying is a little bit, or the probability of surviving is a little bit lower than this for a 32-year-old male. So we would have to change that. But for 31-year-old males, they are making $42.79 on average for each male that is insured. Okay, so that's kind of how this plays out, why insurance companies on average are making money. Okay, so not necessarily gambling always. This is another example of how the expected value, that's what they call this, expected value, plays out. Okay, just create a table for it, and you're finding the mean of the probability distribution just like we did in the last video. Okay.